Welcome to In 5 Minutes. We are discussing generation of double sideband full carrier. There are two approaches used in the generation of DSB-FC. In the first approach, we use flywheel effect along with the class C amplifier to generate the AM signal. The second approach is the use of mixer. To understand this, let us first discuss what exactly mixer is, what does it consist of, and later on we will look at the detailed circuits of generation of DSB-FC using mixer approach. Mixer is going to be very important block in many of the block diagrams later on. For example, in the receiver circuits also we will be using mixer. So make sure you understand what exactly mixer is and what kind of output mixer generates very well in this particular video clip. The very first thing which you will always remember is that mixer always takes two inputs. In other words, two frequencies, because every input signal will have a specific frequency, or it can also have a range of frequencies. It may not be single frequency, but in most of the cases one of the two signals will be single frequency signal. As of now, let us keep things simple and say that the first input to the mixer is signal A1 cos 2 pi f1t. In other words, the frequency of the first signal is f1, and let's say the second input to the mixer is A2 cos 2 pi f2t, which means that the frequency of the second signal is f2. Now, what is mixer? What does it consist of? Mixer is nothing but a circuit made up of a non-linear device. NLD here stands for non-linear device. Now, what are non-linear devices? We have any transistor is nothing but a non-linear device. For example, BJT. BJT is a non-linear device. So if you make a circuit made up of BJT, that whole circuit can act as a mixer. So mixer, please remember, is nothing but made up of a nonlinear device. The detailed circuitry we'll see later on. Now let us see what are the outputs of mixer. Now why I'm saying what are the outputs, that means there are multiple output components present at the output of the mixer. The very first output component will be the fundamental frequencies. The fundamental frequencies are nothing but frequencies f1 and f2. So the original signals cos 2 pi f1t and cos 2 pi f2t will come at the output side. Their amplitudes might be different, not original amplitudes a1, a2, but the frequencies will be f1, f2 at the output side. This is the first component of the mixer. Because of the non-linearity of the mixer circuit, there will be some extra frequency components generated. Now what will be these extra frequency components? The first will be the harmonics. Now when I say harmonics, harmonics are nothing but the frequencies like 2f1, 3f1, 4f1, so on and so forth. These are the harmonics of f1. This is second harmonic, this is third harmonic, this is fourth harmonic, and there will be harmonics of f2 also. So we will have 2f2, 3f2, 4f2, so on and so forth. So the second set of frequencies is nothing but harmonics. The third type of output components are called cross products. What are called cross products? Cross products are nothing but every possible combination of mf1 plus minus nf2, where m and n will be nothing but the integers. So when I say mf1 plus minus nf2, what does that mean? Let us take m1 equal to n, m equal to n equal to 1. If m and n are equal to 1, then what are the frequency components that we will have? We will have f1 plus f2 and f1 minus f2. Now m and n will take all the variety of combination. Let's say m is 1 and n is 2. In that case, the frequencies that I will generate will be f1 plus 2f2 and f1 minus 2f2. I can have the case where m is 2 and n is 1 possible. In that case, the frequencies I'll generate will be 2f1 plus minus f2 and so on. So if you generalize this whole nature of the output, then you see that every possible component of the frequency will be present on the output side. Obviously, not all the frequencies will be present with the equal amplitude. The frequencies will be present with varying different amplitudes, and some of the frequencies may have very small, very weak amplitude that you may not even recognize, or you may not even record them on the output side. But some major components with considerably high amplitude that will be present will be fundamental frequencies, few of the initial harmonics, maybe second and third harmonic, and few of the initial cross products, which are f1 plus f2, f1 minus f2. So these are the frequencies that will be present with good high amplitude, and the remaining frequency components will be having the decaying amplitudes. But yes, that will again depend upon the nature of the nonlinear device. But I can make that statement for most of the practical nonlinear devices. So that's how mixer operates. Now, how will this mixer help me in the generation of DSB-FC signal? It's very simple. In case of F1, we will give, let's say, my modulating signal, which has the frequency of FM. In place of F2, I will give the carrier frequency, which is FC. On the output, we will have variety of frequencies. Out of all those frequencies, we will extract the three frequencies, which are FC minus FM, which will be of the form F1 is FM and F2 is FC. So if I apply F1 as, let's say, FC, the carrier frequency, and F2 as, let's say, FM, which is the modulating frequency, then from all the variety of frequencies which will be generated on the output side, we will be keeping frequencies starting from FC minus FM, which is the lower sideband frequency, the carrier frequency, which we need because it is double sideband full carrier, and FC plus FM, which is the upper sideband frequency. And these three frequency components will define DSB-FC. So how do we extract these three components, and what happens to other frequencies? We simply use bandpass filter. Using bandpass filter, we will only extract bandpass filter centered around FC with the bandwidth of twice FM. We will extract these three frequencies, and we will remove all the other frequencies from the final output signal. So mixer, the use of mixer is one approach in the generation of DSB-FC signal. And let me emphasize on this point that mixer makes use of a nonlinear device. So this whole approach is possible because of the nonlinear nature of the device that we are using in the mixer.